Hello everybody and welcome to Carolyn Covery revision sessions. The session this evening will focus on GCSE physics and in special the QER questions. It will be presented by Dr Nettle from e-sgol Gymraeg a Sylvia. The session will last around 45 minutes where I will run through the relevant content. If you have any questions during the session, please use the question and answer section and we'll do our best to answer you. You'll also see there's a hyperlink in the Q&A section. If you're happy to leave your name and email address, we would love to keep in touch with you so that we can send you information about future events. You can click on the link at any time during the session. Today's session will be recorded and the recording and any relevant resources will be uploaded to the e-sgol website under the Carolyn Cymru tab. Thank you. So in today's session, we're going to focus on QER. We're going to understand what a QER question is, how it's typically assessed, look at trying to plan and the best approaches to planning for QER questions, and then even look at some recent QER exam questions and maybe feedback of what they'd like to see to improve marks from it. So looking through the content that's on Carolyn Cymru website, I can see a lot of the units you should have learned have been done in different sessions, and some of them have been gone through twice. And I thought one of the things that stood out to me was QER and how those longer QER questions haven't quite been covered, and I thought this might be the best thing to do for today's session. So last session we looked at revision techniques, and this is one of the things you can focus on, is have a whole session around the QER. So QER stands for the quality of extended response, and taken directly from the WJC specification, you can see that for each series, so this includes biology and chemistry, there will be an assessment for QER where they'll assess writing accurately in specific questions that require an extended writing. This goes from double award, units 1 to 6, or if you're doing a standalone physics, chemistry and biology, it counts for both units there, so the year 10 and year 11. So how this is marked then is what they're looking for is for the candidate, so you, to write accurately, and it also takes into account the use of specialist language to demonstrate you understand the keywords in describing the phenomenon or the physics experiment. It also takes into account your ability to spell, punctuate, grammar, and use good reasoning to explain what the question asks. So if we think now QER is not quite the same as just answering a question or calculating a point or plotting a graph. What they look for and what you need to be thinking about is, first, when you approach a QER, what you'll see is those square brackets on the side where you might have the 6, but you also have QER labelled. You know this is where they will assess you on that question for the whole exam. And it's often on the front page of your exam with all the writing that a lot of you might skip straight away. It'll quite often say the QER question will be on question 4 or 3. So QER, quality of extended response, what you first want to do is look for command words. So describe, evaluate, explain, so that you know exactly what you should be targeting first. This tells you what the examiners are likely to be looking for. And typical words can be describe or explain or even evaluate. The second thing you might want to do is, if you use highlighters or you have one pen, go back over them and either highlight, underline, or pick out the key bits, circle the words that you need to focus on. You might want to plan the structure of the question and therefore plan the structure of your answer. So you might want to use a part of the page to lay out the structure so you understand what type of paragraphs, or even sometimes the question might say, using the aid of a diagram that you would draw, explain a process. So you might want to think what diagram would best help support your answer. Once you're ready, you've got an idea in your head, that's when you should approach writing the answer. Think about the structure in mind and follow it. And at the end, always read through your answers. It's no good writing it once and then not checking to see if you've ticked off all the keywords or all the command words. So check your answer fully. and make sure that it does cover all of the command words and has explained each one clearly. And then finally, because of the QER element, it's worth checking that you start each sentence with a capital, you use correct punctuation and grammar throughout. So try to avoid using bullet points or numbered bullet points as I have here, because it does not suit the QER questions. So if we think now, you might have a low level, mid-level or a high level answer. What typically constitutes a low level answer? Well, think about your structure. If you demonstrate a basic understanding of science involved with very little detail, and you might have lots of gaps in the sequence, you're starting to put yourself into that lower level of answering. If you don't sit and think about how to structure your answer so that the stages are not quite in order, again, you're putting yourself into a low level answer because you're missing that extended reasoning. If there's a lot of irrelevant information because you haven't focused on the keywords, that again is starting to put you into that bracket. Or if there's a lack of connection between points. So you've explained one point and the fifth point, however, you're not able to branch between the first and fifth by explaining the second, third and fourth elements of the question. So hopefully we'll get to see some of this in a moment. If you move to a mid-level question, what you might be thinking about now is, what else would you need to do? Well, starting to show that understanding of the scientific ideas. So not all of them, because you're allowed to have a few inaccuracies here or there, but you overall have an understanding of the ideas and it's clearly shown in your work. Nearly all of the detail is present. So first, ensuring you tick off those keywords and command words, you start to actually structure your answer. That way, it'll be clear when you have a good structure of what each command word has asked you to do. When reading through your answer, you demonstrate a mostly clear and coherent answer, where you may only be missing some minor points. So hopefully, when you're thinking about your work, this is something quite achievable, because first thing you want to think about is the scientific idea. Once you start going through the command words, you start to notice you can picture the order you would want to write. And from that, a natural good structure should come out with a clear answer. So as long as your revision has gone well, then the understanding of the scientific ideas should be there ready. It's just a case of using your knowledge, but also understanding how to best answer QER questions through focusing on those keywords and command words. So the final bit would be a high level answer. High level answer will hopefully demonstrate a full, accurate information from top to bottom. The candidate clearly understands the question and can answer it clearly with relevant information. It's fully detailed, so all of those command words have been fully explained clearly, with no missing information and no irrelevant information. That way then is the clear, good structure and a coherent answer that is logical, with all of the statements coming from the understanding in physics. So from this low, mid and high level marking, what you might want to think is, these are the little bands you might have heard the teachers try to explain, where the high level is the 5 to 6. The mid would be the 3 to 4. And the 1 to 2 puts you in the low level answer. So when you look at the type of stuff that puts you in the high level answer, you will see a lot of it comes from accurate information with good detail. And only then does the structure come out of it. So first of all, you should be thinking, get the physics correct, because if you can detail all of the physics correctly, it should put you up in that higher level. It will only then come down to how clear and coherent your answer is with logical steps differentiates between that 5 or 6 marks. So please focus on that understanding to put you in the higher band before you think about that structure. So moving on now, I hope we have a good understanding of what QER is. We have an idea of how it's assessed. So again, focus on the physics and then consider your structure and punctuation. And now we can look at some planning examples. So instead of focusing on a single unit today, what I've done is pulled out a recent 6-marker or a recent QER question or some example QER questions that I use with my class just to see how best to approach them. We won't necessarily write out a full answer. What we'll do is consider the information needed to answer this question for you. And then it's up to you if you're going to practice to answer them in your own time. If you're watching this back recorded, there'll be opportunities for you to pause, try and answer fully. And then as we go through what would make a good answer, what content they would look for, you can attempt to gauge where you would fit on a high, mid or low level. So the first one would come out of the unit speed, distance and acceleration. Then you can see again here that symbol 6 QER. What we have is a velocity time graph. So it's not just a question explain this or explain that. They're actually giving you something to read. So we have a velocity time graph for an empty school bus, and it shows part of the motion. So this sentence here is starting to give us some of the information we need. However, as we look a little bit further, part A, use values from the graph to describe the motion of the bus over the time shown. And in brackets, it says note that no calculations are required as part of your answer. So looking at the command words, you might want to pick out values. So you want to use the values. Where do you get the values? From the graph. So make sure in this type of question, you want to fully use the graph to describe the motion. So they expect you to describe the motion of the bus in that time interval. And an important one here is that it says not to use any calculations. So in higher tier, some of the stuff you could calculate is the distance and the velocity time graph. In any tier, you should be expected to calculate the acceleration and deceleration. However, by saying not to calculate, do not do the calculations because they are not going to help you in gaining the marks. What you might want to do is naturally lead to the calculations through describing the motion. So what we want to focus on first is breaking this question down. So first of all, you might want to think, okay, the values from the graph. If we look at the graph now, a lot more information should come up. So you might want to think about answering the question from looking at how can you break down the journey of a velocity time graph. So hopefully it's clear, but you might want to think, well, if I treat each phase of motion as a paragraph or a chorus of sentences, then you might have A, B as being the first thing you might want to do. You might want to look at B to C. You might want to then describe C to D separately, D to E, and E to F. What you might notice as you try to pull out information like this before you attempt to write, you could be thinking along the lines of, well, this is starting to form a table. I can see now A, B, B, C, C, D through to F. There's different motion in each step along. So A to B, you might want to think, what are your keywords that describes A to B? Well, if you see there's a change in velocity from 0 to 25 meters per second. So you might want to put here, what is the numerical change? Thinking about how you structure this answer, look at the numerical change. Before you start answering, you could think, what would go in your sentence? Well, the first thing might be an understanding that the speed goes from 0 to 25 meters per second. And it might be useful to mark on your graph the time in which this occurs, which would be 50 seconds. So now you think of your sentence you can already say that the motion of the empty school bus begins at time 0 and increases in velocity to 25 meters per second in the first 50 seconds. Can you describe this further? Yeah, you can. Through looking, if there's a change in velocity, it's either an acceleration or deceleration. So you might want to say what keyword fits there. You might want to have acceleration. I put ACC for short, so an acceleration has occurred. B to C is a way of identifying the motion, and you can see it's a flat horizontal line, and through your revision you would remember this demonstrates a constant velocity, and that constant velocity is 25 meters per second for the time interval from B all the way through to C. So this now requires you to read the graph, and reading the graph you might find that it's from 50 to 100, which is a gap of 50, and in addition to this there are an additional 30 seconds, so that will be for 80 seconds, and you might want to think the keyword would be constant velocity. So you can repeat this all the way through for each segment, and what you'll find is you might have the matching content to what they'd expect to find, and you've done this through breaking the question down into each segment. So there's a reason why they put the A through to F, because it helps you identify what to discuss. And if we go through each step, we can see what we identified was an acceleration from 0 to 25 in 50 seconds. So that they'd expect to see a nice reasoned sentence discussing the motion from A to B. In addition, B to C, we did identify a constant velocity for 80 seconds at that 25 meters per second. And in their marking scheme, you can see again, they ideally want you to repeat this all the way down. And by having so many different changes in motion, this is why the emphasis is on not calculating, but a clear description of the changes. They have put an additional bracket here with this developed idea. So as your reason has developed, ideally the best responses would start to demonstrate these additional features. For example, from C to D, it is not a straight line, it is curving, which demonstrates an increase in deceleration. So that deceleration is increasing because the gradient is changing. In addition, some of the additional things they'd like to see is that there is a constant acceleration from A to B and E to F. So from all of this, a candidate looking for that 5 to 6 mark category would have a correct description for the whole motion with a good coverage of all 3 description areas. So they've identified 3 different description areas. So you can see it's quite obtainable if you break the question down in this style. So 6.1 covers speed, distance, and acceleration. Ideally, this is the style of question you'd be looking forward to. If not, we would have to look at maybe Newton's laws. So what I've done here is I've put down a 6-mark question, and right next to it I put another identical question, but here I've underlined and highlighted to see if it's more clear. So take a moment to look at the difference from underlining and highlighting. So what you can see is the question that states, when a skydiver jumps out of a plane, I've underlined that to identify this is the scenario that we're considering. The forces acting upon them change. So keywords, the forces change as they move towards the ground. So there's a movement to the ground. Describe the different forces acting on a skydiver. So a question like this, you might want to think, what would you approach first? Well, you might want to describe the phases. So you might want to recall what happens to a skydiver and plan the question out. You might want to use part of your exam paper where you have the additional page to set out a little table again to help plan, or you might be able to think of the steps in your head. But now that we've identified the command words, we can approach the question. So we can think about the steps, first of all, that you would like to cover. So the first step for the skydiver is obviously the moment that they leave the plane. So all we are doing is thinking of the scenario and breaking it down into separate phases. So just like the velocity time graph, if you can break it down into the little phases or segments of the scenario, you might be able to structure a clear extended reasoning. So leaving the plane, you might then have a short time after where you demonstrate an acceleration. Obviously there's an acceleration as the skydiver falls towards the ground. Following that fall to the ground, you hopefully would remember the keywords terminal velocity. So you might want to consider describing the terminal velocity. Terminal velocity, hopefully you identify the parachute being opened after you reach terminal velocity, which would cause a decrease in velocity, but we'll focus on parachute would be the next phase I would look towards. And then obviously the final phase, you might want to say to reach the ground or otherwise. So I'll leave that one blank. That would just be the part to finish. So 4 clear, distinct phases to look towards. So think about this now, leaving the plane, what keywords would you want? And remember, the keywords they are looking for are all involving forces and any change. So you might want to be able to describe upwards, downwards, and name those forces. So as a skydiver leaves a plane, what you might want to describe is an acceleration. What other keywords would we be looking for? Well, maybe the force of gravity would have to be in there. And you might want to link this to the person's weight, the skydiver's weight. As the skydiver accelerates, you might want to then possibly remind the examiner that you understand that the force of gravity is constant. This would be one to identify so that you demonstrate you understand that the force of gravity, the weight of the skydiver would remain constant. What's happening is an acceleration that is at a decreasing rate. But again, those are motion terms. We're looking for force terms. So the force that causes this would be the air resistance. And you might want to identify that the air resistance would be increasing on this phase. Once you reach terminal velocity, you might want to identify the criteria that determines if object reaches terminal velocity. So you might want to talk about the resultant force being equal to the difference in weight, that's skydiver's force of gravity acting on their mass, compared to the air resistance. And this at terminal velocity would be equal to 0 newtons. This is one of the key ones. What else you could describe here is that their motion remains constant, the speed is constant, but again, remember the question is focusing on forces, so it's not necessary. And then finally, what happens when the parachute opens? You might want to emphasize an understanding of air resistance being greater than weight here, which would cause a deceleration, and you might possibly want to demonstrate that you'd have an additional new lower terminal velocity as a result of the air resistance being greater than weight decelerates to a new lower terminal velocity. So what we could do now is think if this strategy helps and works for you, we can look at the answer they were looking for, or the criteria or some of the content that made a good answer. So here's an example, a clear paragraph that says just after the skydiver leaves the plane, the force of gravity. So hopefully you're focusing here and you can see some of the keywords if we highlight them. So the force of gravity here, that's not a highlighter. That's better. So the force of gravity pulls them downwards. So we demonstrate an understanding of what the force is and the direction, causing an acceleration. The acceleration is downwards, and the upwards force of air, resistance is increasing. So again, like we just demonstrated, we understand first phase is leaving the plane. Second phase is that acceleration that might be decreasing. And the acceleration will continue until the upwards force from air resistance and the downwards force are equal. When the forces are equal, there is no more acceleration. So looking at the key command word of forces, you see there's a lot more emphasis on forces instead of speed and acceleration here. They have identified the keyword terminal velocity, so you understand what happens at this point. And once the parachute opens, the surface area increases. The increase in surface area leads to an increase in air resistance. So we can see they are linking what happens to a parachute to the increase in air resistance. This causes the air resistance to be greater than the acceleration, or greater than the weight, possibly, and the skydiver will slow down or decelerate. And you can see the final bit they've added in is that as the skydiver slows down, the force from the air resistance reduces. And they've also identified a new, slower terminal velocity is reached because the upwards and downwards force are balanced again. So here, ideally, this candidate demonstrates clear understanding of the physics principle, which is the forces acting on a skydiver. They've also shown a good structure because the steps are logical, and then hopefully this type of question is easy approach because it allows you to do it in clear steps. So 6.2 Newton's laws hopefully is a nice skydiver question which allows you to demonstrate your understanding of forces and how they change because of the acceleration. If we looked at a question from 6.3, we might see something that looks like this. Work and energy. Quite a big unit, so you could get 6-mark QER question on energies or changes in kinetic and potential and describing the motion and how that affects energy. Because you also study Hooke's law in this unit, the F equals kx of springs, you could get an extended question on that, or even because of the final point in the specification, the understanding of cars, you might get a question on safety features. And this is what one example. So we have seatbelts in cars were not made compulsory in the UK until 1983. Before this, 6,000 people a year died in traffic accidents. Since then, the number has decreased year on year until in 2015, 1,732 people were killed in car accidents. So obviously this is information trying to set up the idea of seatbelts being a safety feature. So seatbelts are not the only safety feature in cars. Describe some of the safety features that are in modern cars. So a question like this now is quite useful, but also one you might need to take care in approaching, because can you see how if you try to identify the command words, you might navigate quite quickly to the keyword of seatbelts. So obviously it starts with seatbelts right here, and you might be thinking, great, I understand seatbelts, I can explain seatbelts quite quickly and quite easily. However, a large part of it is that towards the end, they say seatbelts are not the only feature. So by identifying one, they're essentially telling you to exclude it in your answer. So if you were to go through the question before starting, you might want to identify that that's something you wouldn't explain because they have done that for you. So identifying a seatbelt would not help in improving your mark. What would is seeing the command word of describe and the command word of some. So describe some of the safety features of modern cars. So by saying describe some, you are looking to describe more than one. So first thing you'd want to do is recall what potential safety features there are in the car. So if seatbelts are excluded, you might want to go back and try to remember what features we have. So in your revision, you might have focused on 1, 2, 3, but always remember some questions like this will essentially, if you're only learning one and hoping that's the one you can use, you might be stuck because of this example here. So without a seatbelt, you would have two options. And in this 6-mark question, there's a lot of work to do because you're either talking about airbags or crumple zones to get you into that lower or middle tier. Looking at that higher tier answer, that higher level answer, you'd be able to describe two of them fully. So first thing you might want to do when you're planning your answers, think what could you describe about each one? So hopefully they identify here two clear phases to the answer. So an airbag is a cushion product that prevents the person from moving forward and reducing the acceleration as they are expanding. You might want to try and remember what the crumple zone does, and that one you might want to link into work and energy. So hopefully you remember that the concept of crumple zones and where the front end of the car is designed to crumple or change shape and absorb that energy from impact, which reduces the energy transferred to the passenger or driver in the vehicle. But given that this is a 6-mark QER, if we're describing the features, one of the descriptions for safety features is what actually is being reduced. So you might want to describe the force, the energy acting on the person. So we try to think about it. You would have two clear, distinct descriptions, one for the airbag, one for the crumple zone. The idea that airbags reduces the acceleration because it absorbs the person as they go forward and enables them to start accelerating from the moment they touch the airbag to the moment it fully stops moving, as aside from direct impact with the steering wheel. Crumple zones, hopefully you'll be able to have a full description of them absorbing the energy in the process of changing shape. And the last thing you might want to focus on is the idea of point of safety features, which is to reduce the acceleration, which in turn reduces the force by linking it to Newton's second law. So here, some of you might have missed out because you've not tried to use physics fully in description or tried to use an equation to help better your explanation and make it as clear as possible. So 6.3 is working energy. If we look towards what other questions we have the unit 6.4 if you're doing double award, which would be the stars and planets. And that type of question would hopefully be a nice question to approach, especially if it was one like this, taken from the sample assessment material on the WJC site, which you can access. As a question that says, the solar system consists of the sun along with a variety of different objects and planets. Name these and describe some of the features and their positions. So this is a very nice question with lots of opportunity to fully describe features. So first of all, can you see how they have focused the question on solar system and what it consists? They've named the sun, but they've not named the planets or the different objects. So this is your opportunity, especially when the command word is named. So seeing this, you should be thinking already, what are the names of the planets and the different objects? At the end of the sentence, it also says relative positions. So now you might be thinking back to your revision techniques, and if you may have learnt the names of the planets through a nice method, like using a mnemonic to help you remember it. Describing some of the features will hopefully come in for identifying your understanding of properties of planets, being rocky or gassy. So what we're going to do now is, instead of trying to plan the question out, if you're watching this back, you might want to pause it and give it a go yourself, plan your answer, work through your answer, and then compare it to a standard answer that they would have seen. So a standard answer that has a lot of the content is something like this, which is there are 8 planets in the solar system, and the planets in order from the sun are Mercury, Venus, Earth rather than Earth, and Mars and Jupiter and Saturn and Uranus and Neptune. So hopefully something that stands out already is the potential grammar errors and not necessarily the lack of physics. So if we focus for a moment on the standard of physics, we can then go back and identify the level of description. So straight away, they've identified 8 planets and the order. So they've named, and they've also achieved a good demonstration of the relative positions. Some of the inner planets have small number of moons, Earth 1, Mars 2, but the outer planets have many moons. The further away from the sun, the lower the temperature of the moons and planets. So here now the sentence is slightly difficult to read because of the structure, but again, they've identified inner and outer planets. They've not described where the inner and outer starts, but again, a good attempt. And the orbit time around the sun increases as the distance from the sun increases. So they've described another feature of planets in our solar system. The solar system also has dwarf planets and small comets, which are made of ice. So here is a good attempt. So you might want to think, have they done enough? So again, remember, you're thinking of bands that you might fit into. You might have made some mistakes spelling here or there, but that shouldn't stop you from reaching the 5 to 6 or 3 to 4 band, the upper or middle level, just because of the structure or reasoning. So if we look at the middle band, as the candidate explained most parts of the solar system, such as planets, moons, asteroids, comets and dwarf planets, well, the only thing missing there would be asteroids. 5 to 6, can you see all parts of the solar system named? The order of planets is evident, which isn't part of the middle, it's part of the upper level answer. They've detailed the composition of the planets, so rocky and gassy. So here that has been missed. They've also missed the asteroids and a detailed description of the features. So you can see here now that the candidate would fit into one, not both of those bands. And then when you look at what would put them at the upper or lower, you need to think. This is why we say to read back through your answers. Hopefully you would pick up the fact that Earth has the H in it, and the fact that you might have used and with another and here. So you can correct these things to put yourself at the top of each band. That way then you do have a line of reasoning that's partially coherent rather than quite difficult to read. And there's full relevant support with your evidence, or even a sustained line of reasoning with logical structure. So think about how you write it and how you read over it to check that you have achieved the full marks. So hopefully, if you read back through it, you might have the opportunity and time to correct yourself. So if we look at doing that, if you were the type of person that would did that now, you could start to fix these things and have an answer that looks a bit better like this. So there are 8 planets in the solar system. The rocky inner planets in order from the Sun are Mercury, Venus, Earth and Mars. The outer planets are much bigger and they are made of gas. They are, in order of distance from the Sun, Jupiter, Saturn, Uranus and Neptune. The planet furthest from the Sun is Pluto. Between Mars and Jupiter is the asteroid belt, which contains rocky objects which have never formed into a planet. Some of the inner planets have a small number of moons, so 1 for Earth, 2 for Mars, but the outer planets have many moons. So you can see now it's a lot clearer to describe the planets, positions and features of the 8 planets. Generally, the further away from the Sun, the lower the temperature of the moons and planets, and the orbit time increases. The solar system also has dwarf planets and small comets made of ice. So here you see the answer has all parts of the solar system, all planets in the correct order, composition of planets, and a good description of features. The answer is quite easy to read because there is a sustained line of reasoning which is coherent, and there's a good logical structure. So again, hopefully we see this is a very good answer for this type of question. The 6.4 question hopefully would be a nice one to come up because it enables you to fully demonstrate your understanding of the solar system, or it could even be about the life cycle of stars. After 6.4, we get 6.5, radioactivity. A question from radioactivity ideally would be of this type, which is that radioactivity is useful and dangerous. It needs to be carefully controlled so it doesn't harm those using it. There are 3 types of radiation. Describe these different types. So again, I approach it by looking at the command words, from identifying the command words such as radioactivity being the topic, usefulness or dangerous, controlling it carefully, so you might want to mention controlling it, but then the question asks you to identify 3 types and describe the 3 types. So hopefully from your revision you feel quite confident and you could jot down a few notes about the 3 types quite quickly. So hopefully you remember that the 3 types are alpha, beta and gamma, and when you think about it you may have from your lessons a summary table or a knowledge organizer, and this is the type of information you might fully have a good grasp on already. So alpha, remember that it's a positive helium nucleus that comprises of 2 protons, 2 neutrons. Properties of this is that it's highly ionizing, but its ability to penetrate is low and it's easily stopped by paper. The beta radiation, the things you need to know and demonstrate is an understanding that it's an electron, therefore it's got a negative charge with a medium ability to ionize and penetrate, but it can be stopped by aluminium. And the final type would be gamma radiation. So hopefully your answer, you can identify gamma radiation being an electromagnetic wave that has no charge, no mass, and it has the ability to penetrate deeply through materials, which is why it needs to be stopped by thick lead. So in today's session, what we've done is we've identified and understood the definition of QER, the idea that QER stands for quality of extended reasoning. We've understood how it's assessed, and this idea of you want to demonstrate the best physics knowledge possible to put you into a low, middle, and ideally a high level answer, so that when it comes to your grammar and punctuation, you can read back through it to give you the best opportunity to get those 6 marks if you put yourself in the higher band, or the 4 marks if your physics can get you to the middle band. From understanding it, we've looked at some planning examples. Those planning examples has gone through each of the units we have studied so far, and we've looked at some of the marking schemes to see how to structure it through using command words to really identify how best to solve these questions. What I've left at the bottom of the PowerPoint, which will be on the website, is some recent feedback and guidance you might want to look at that identifies what normally goes well or what normally doesn't work so well in the answers. So I hope you found today's session useful. There will be a session next week and the following week where I will look to answer a full past paper, a foundation and a higher tier for the double award, best help most of you, and we hope to see you then. Thank you and goodbye.